One thing I've noticed is that a lot of times students don't pay attention to things unless I explicitly point it out. So here's this web thing that I gave you, and you've all got much better web stuff. But as you read through this, how well do you feel you understand all of this gobbledygook? Feel like you nailed it? Okay, well, I just want to point out what exactly you're reading, because I'm not sure this was explicitly stated, and this leads to the next topic I want to mention. What you're actually reading right here is another language. This language is called HTTP. It stands for Hypertext Transport Protocol, and it's not the same thing as HTML. HTML is usually what's in the body of HTTP, and this is the body, and these are what are called header lines. And HTTP packets have two parts. First, a whole bunch of header lines, and each of these header lines is terminated with a carriage return new line. And they always have name-value pairs, so the name separated by a colon, and then a space, and then some value. And you have header, 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 and then a blank line. And after the blank line is the body of the packet. And then I cut it off with dot, dot, dot here because I didn't want to print the whole thing. It would spew out too much stuff. But basically, this is HTTP. Okay? This is the client side of HTTP. And this is the server side of it. And this is the client side of it. And this is the server side of it, and so forth. Okay, what's good about HTTP? Well, here are some properties of HTTP. One is, notice that it's a text-based protocol. Back in the 80s, all the programming, whenever we wrote stuff, there wasn't enough space, right? Remember with 3.5-inch floppy disks that had like 1 megabyte on them, and that was so much space. And all of our computers had 64K of memory. Back then, space was important, and so everything was encoded in binary formats, and everything looked like this. But then about the 90s, we started to realize, hey, computers have tons of memory now, and text-based everything became awesome. So HTTP is a text-based thing because 90s are when the internet came out. And, well, it's been text ever since you guys were born. So from now on, everything is supposed to be text-based. You notice AJAX is a text-based format for encoding stuff, and HTTP is text-based. Why do we like text? Because debugging this kind of garbage is a pain. You can only write programs to do the debugging, and it just takes super long amounts of time. But if there's a bug in the text, a human can look at it and find where the problem is. Okay? Why do you need to know HTTP? Yeah, well, you're computer programmers now, and HTTP is the language of the web. Therefore, the more you know HTTP, the more you can hack it. So let's look at this. The first thing you do in HTTP is you specify a command, such as git, or git, or git, or, come on, git, or post. Okay. The two most common commands in HTTP are git and post. There are others. There's one called head. There's one called, I can't remember. That's not it. It's something else. And you could Google it, and you could learn what all the HTTP commands are. But basically, they all behave in a different way. When you do a GET request, you specify what you want to get right here. And this is called the URL. Stands for Universal Resource Locator or something like that. And then you specify the version of the language that you're talking. And you always speak in HTTP/1.1 because that's the version when the web totally took off, and now it's too late. We can't undo it anymore. Okay. Then there's this header line here called host, where you specify the name of the host you're trying to talk to. This was actually they didn't used to have this line in HTTP. But it turns out that sometimes you want to host multiple domains on a single web server. And if you're doing that, how do you tell which domain they're supposed to be talking to? Well, this line in the HTTP header tells which domain they think they're talking to. And so that allows you, when processing HTTP, to say, oh, this one was supposed to go to myname.com, and that one was supposed to go to some other name.com. And that allows you to specify that kind of stuff. If you're configuring Apache, it's kind of important to know what this stuff is about so you can set it up to manage your host. Here's some stuff you might not have noticed. Did you notice that whenever your web browser talks to a server, it rats on a whole bunch of information about you? It says, hey, this is what web browser I'm using, and this is the version of your operating system, and this is the kernel, and hey, look, there's the version of your browser, and here's the version number. Basically, every time you visit a website, your web browser is just handing out personal information right and left. Here's a bunch of details about the user that's visiting you. How do you feel about that? It's kind of annoying, right? Well, welcome to the web. That's what's going on these days, is your browser hands out lots of information just when you visit a web page. And do servers log this information? You bet your buttons they do, because data has value in modern times. If you know anything about data mining, and you don't yet because you just learned how to program, but there's a thing called data mining where you use math and computers to extract value from data in order to figure out things like what coupons are these people likely to respond to, and what products should we try to sell to them, etc. And you can actually turn data into money. Well, consequently, every company out there that cares about money, which is all of them, is gathering all the data they can, which means everything your browser says they're going to steal. Way back in the early days of the web, a lot of websites used to say, this site was optimized for Internet Explorer, and only if the user agent site line said Internet Explorer, the website would work. And if you said something else, they'd say, sorry, your web browser is not acceptable. Turns out most browsers allow you to tune this line, so you can actually specify some other browser and fake like you're using that browser, but it's really this browser. And that allows you to get past those dumb websites that are poorly configured. These days, though, every good website is configured to work on every browser because the browsers have finally standardized. So now it's not that hard anymore. And yeah, we'll talk more about tracking you in a minute. OK, except this basically says what your browser is capable of rendering. And blah, blah, blah. Connection keep alive. This means, hey, you don't have to hang up on me after the connection, after you send this to me, because I'm probably going to ask for something else. Our program doesn't use that, but it's a thing. Can be done for more efficient browsers. And then there's an interesting line here called cookie. Anybody ever heard of a cookie before? What is a cookie?
It's like the internet that your computer keeps track of the different cookies on websites, like using the passwords and all that.
Kind of, yeah. If I were a better professor, I would have brought a tray full of cookies just to illustrate that we're learning about cookies today. But I'm not, so deal with it. Now, so what's all of this gobbledygook? Yep, that's the cookie. Now, there's actually a line that the server will usually add that looks like this. Open a text editor so I can type. The server will say set cookie colon gobbledygook. And then this line will be in the HTTP header that the server sends back to the client. And what's supposed to happen is the client is supposed to take this information and store it somewhere on the client's computer. So your web browser somewhere has, probably in the file system, there's a file that has all of these cookies that the servers have sent to it, and they're basically there to give the server a place to store data on your computer. So you're storing data for every website you've ever visited, and it's called a cookie. That seems kind of cheap, doesn't it? Well, in order to make sure it's not abused, I think there's a limit, and it's something like 4096 bytes, 4K. bytes, something like that. Now, it's not exactly that. It's off by a little bit, and I can't remember how much. But there's some very small limited amount, so the server can't basically dump all the storage information they want on your computer, but they can store enough that it makes a totally unique ID. Is that a unique ID? Yeah, if you've got more than 10 digits, it would be pretty almost impossible to just randomly guess that thing. Yeah?
So two questions. First of all, what is the goal from cookie? And then, why the cookie start in the computer?
Okay. One, I'm getting to that. And two, I'm getting to that. If I don't answer that in the next 20 minutes, ask again. Okay, yeah.
What is the difference between a cookie and a cache?
A cookie and a cache? So a cache is where your browser stores copies of all the web pages it has ever downloaded from the internet. Remember back in the 90s when we all had 1200 baud modems? You're like, no, I wasn't even born back then. Well, back then the internet was friggin' slow, and we didn't all have fiber optic connections to our ISPs, and we didn't plug into the fat pipes of the university. And so it took a long time to download a web page. And so we didn't like downloading web pages. So the web browser cached the pages you visit so you wouldn't have to go there again. This causes lots of headaches when programming, because if you have an old copy of the web page in your browser and you update the code, you might not see it unless you hold down the Shift key and press the reload button. Why do you have to hold down the Shift key? Because you might want to just reload from your cache, and the Shift key says, no, reload from the internet. Okay, so that's what a cache is. A cookie, so a cache is for your browser's use. A cookie is for the server's use. So I go to visit uark.edu, and they say, hey, I want to store a unique identifier on your computer. Why would they want to uniquely identify me? Yeah, so that when I come back, when I visit uark.edu again, they can say, oh, hi, Mike. Welcome to uark.edu. Or they can do other things, like count how many times I visit their web pages and discover that, hey, everybody that visits this page also visits this other page, and other types of data. Basically, cookies exist so that servers can store data about you. Okay? So what if you don't like cookies? In your browser, there's an option to clear your cookies, and there's an option to turn off your cookies. Have you ever done that before?
Yes.
And what happens? Yeah, if you clear your cookies, all the websites think you're brand new and they make you log in again. And it's really annoying. And if you go to Google, you get crummy search results because they're not personalized to your needs anymore, right? So for example, I go to Google and I type in speaker, and it tells me I want computer speakers. And I'm like, yeah. And then I go clear my cookies, and I go to Google, and I type in speaker, and it says, oh, are you interested in Tris Speaker, the famous baseball player? And I'm like, what? Because I'm a computer programmer. I don't do baseball. Have you even heard of Tris Speaker? He's a famous baseball player. How did I learn about that? Cleared my cookies, right. So there you go. Apparently, speaker to much of the world refers to a baseball player. Who knew? Yeah. Well, in fact, here is a real cookie right there. And you can see how big that cookie is. So does it make your connection slow? Well, it makes it slower by the amount it takes to send that much information. And that's only a tiny fraction of a web page. So no, it doesn't slow it down a lot. What happens is when you visit a server and the server figures out who you are, they're going to come up with a new random number for you. So this is all just this was probably generated by some random number generator. And what the server is doing is they're saying, hey, if I dump this unique number on your computer, if somebody shows up and they report to me this same cookie, because this cookie line is supposed to repeat back exactly the same cookie that was, the server says set cookie and the client says cookie. You get that? Okay, so if the client repeats back the same exact random number, what are the odds that somebody knew? Pretty darn slim, because you'd never guess that number, right? If you were writing a server, you could stick some information in the cookie, and you could expect the browser to spit that cookie back to you when they connected to you again. And how would you use that? Yeah, in the early days of the web, you used to have to log into a web page, and every time you clicked on a link to go to another page on the same website, you typed in your username and your password again. Guess how old that got? Yeah, really fast, people started thinking, this sucks. Why can't this server remember who I am? Well, how did they fix it? They invented cookies. The idea is, the server says to you, here's your cookie, and because the browser repeats it every time you visit that server, the server knows, oh, you're that guy that's still logged in. I'll not ask you for your username and password for 30 more days. And then after 30 days or so, they make you type it in again, just in case somebody stole your cookie or something like that. Yeah, it's not that the information is stored in the cookie, it's that you've typed in your password and they give you a cookie that corresponds with something on their database.